will be the resultant of the normal reaction and this will be the resultant of a normal reaction and the friction force. So what is R? What is R? R is the resultant. Okay. So basically this normal reaction is also a contact force. Why normal reaction is a contact force? Because there is a contact between the surface and the body, and due to that the force is on the body. This normal reaction due to the contact, na? And friction is also a contact force, because there is a contact, then also there is a friction. So you can say this resultant is the resultant of contact forces, resultant of contact forces. So basically I have already written here contact force. Here in this case we have, one is the friction force, another is the normal reaction, contact force. And this angle is known as the angle of friction. This theta is known as the angle of friction. This theta is known as the angle of the friction when this block is just about to move, so what you can say, when this object is just about to move, means the applied force on this object becomes equal to the static maximum value of the static friction force, that is limiting friction force. Okay.
So here mg will also be there.
Of course mg will also be there. But I am not showing mg. Okay, we are only interested in normal reaction and this force. Okay. Okay, so now if you know how to calculate the value of tan theta, in vector I have told you how to calculate the value of the tan theta. Tan theta will be, so when this body will be just about to move, this friction force will be become limiting friction force. Okay, so you can write this as FL divided by N. What is the limiting friction force? Mu S into normal reaction divided by the normal reaction. This will become mu S. What is mu S? Coefficient of static friction. What is mu S? Coefficient of static friction, I have told you now. So tan theta is equal to mu S. So you can say the angle of friction is tan inverse of coefficient of static friction. So remember this formula. All students. Hello Hiba. Hello Hiba. Hiba, are you listening me? Are you listening me, Hiba?
Yes, sir.
So let us see here. We have started the topic angle of the friction. Angle of friction. Basically, this is a block, and this block is just about to move. And what I have told you yesterday, when some body is just about to move, means the applied force on the body becomes equal to the limiting friction force. And what is the limiting friction force? Maximum value of the static friction force. So this body have the tendency to go in this direction. So friction force is acting in this direction. And I have also told you friction force always acted tangentially to the surface. So this is the direction of the limiting friction force. And normal reaction, you know very well. If you will two force, these are the two forces at 90-degree angle. So there will be some resultant. Two forces are at 90-degree angle. So there should be some resultant now. Okay. If you don't know this, how tan theta is equal to this FL by N, then I am just explaining how. See this diagram, normal reaction R and FL. This is your normal reaction. What is this? This is your limiting friction force. This is your limiting friction force. And what I told you to find the resultant, complete the parallelogram. Parallelogram law means draw a line parallel to this line from the tip of this. Draw another parallel line, and the resultant you will get will be this. This will be the resultant. So basically, suppose this is O, this is A, this is B, and this is C. This is O, this is A, this is B, and this is C. This angle is 90 degree. Okay, now what is OA length? Divyangi, what is the length of OA?
Magnitude of normal reaction.
Yeah, that is N. Basically, your OA is equal to magnitude of the normal reaction. That is normal reaction simply. What is OB? OB is equal to FL, magnitude of the limiting friction force. So what this length of the arrow representing? Magnitude. So basically this is a parallelogram we have completed. So parallelogram means parallel sides are equal. So this OA is N. So this is the parallel side, this is BC. So BC is also no N. Okay. Now this CA is FL. No. This OB is FL. So parallel to OB is AC, and OB and AC are parallel, and in parallelogram parallel sides are equal. So OB and AC equal. So means this is all, this CA is equal to FL. But we know we want this angle theta. Okay. So there are many ways to calculate this angle theta. Okay. If you will not do this and this, then also you can calculate this theta. So remember that in a triangle, if there is an angle theta, suppose this is a triangle A, and this is an angle, right angle at B, and this is C. So this is theta na. So opposite to the theta, you will get the perpendicular of the triangle, and opposite to the 90-degree angle, you will get the hypotenuse of the right angle triangle. This is a right angle triangle, and other side will be base. Okay. So this is the perpendicular, this is the base, and this is the hypotenuse. So if you want to find the tan theta, then how you will find the tan theta? Divyangi, tell me how we will find the tan theta in this triangle.
Perpendicular upon base.
Very good. Perpendicular upon base. Means you can say AB length divided by BC. You can say AB divided by BC. Now this is also a right angle triangle. See, this is also a right angle triangle. This is also a right angle triangle. We want this angle. So basically we want this angle. So This is angle theta, and right angle is here, na? Right angle is here at A. In this triangle, see in triangle OAC, in triangle OAC, right angle at A. This is the triangle right angled at A. Okay. Right angled at A. Now this is the theta, and opposite to theta what is? Perpendicular, and opposite to 90 degree what is? Hypotenuse. And this is your resultant also. This is your resultant also, R. This OC is your resultant. OC is your resultant. Okay, now from this triangle OAC you can find the tan theta. What will be the value of tan theta? Perpendicular divided by base. This is the base. This will be the base. Perpendicular divided the base. So what is perpendicular? FL. What is base? This normal reaction means OA. OA is normal reaction. Basically, see here. This tan theta is equal to perpendicular, that is AC divided by OA. What is AC? AC is FL and OA is N. And what is FL? Limiting friction force is mu S into N, and this is N. Here you will get mu S. So this is the complete way to calculate this tan theta. Tan theta is equal to mu S, and when you will calculate theta, you will get tan inverse of mu. Tan inverse of mu. Write down. So basic knowledge of vector and basic knowledge of triangle you should have. Basic knowledge of trigonometry you should have. Basically what you should know, basic. Write down, you write down basics of trigonometry. Basically basic maths you know, you should know. I want to say that. And there is one chapter vector. So there should be the good command on that chapter, because that chapter is going to help you a lot during your the 11th and 12th. Scroll down. So in static friction, the object state in so basically, what is the inertia? Basically, inertia is the resistance to the motion. Okay, when the body initially at rest, so due to the inertia, the body will uh, try to. Have you completed this, both of you?
Yes, sir.
Okay, so write down and I am explaining. So what happens when the body is at rest and you are applying a force and body is not moving? So first thing is that uh, you can say due to the inertia of rest, due to the inertia of the rest, the body will try to remain at rest. This is truth. Okay, due to the inertia of rest, the body will try to remain at rest. But here is another thing included: friction force. Friction force. Okay, so basically these are two different things. Inertia is when you can say inertia is without the friction force also. Okay, suppose this is a mass, this is some pen, and this pen will have the inertia of rest. This pen basically three types of inertia we define: inertia of rest, inertia of motion, and inertia of direction. So according to that, inertia means if the body is at rest, it will try to remain at rest. So this is a pen. If this is a pen, and I am saying there is no friction force, but when I am applying a force on it, so there will be the inertia also. There will be the inertia also. Okay. So yes, we can say that there is a role of inertia also.
Okay, sir.
Hmm. So when completed, ask me to scroll down.
Done.
Done. Okay. Divyangi also completed. So one question first we will do. Basically, uh, you will learn the concept here by solving the questions. Questions are very important. We will learn the concept by solving more number of questions. Here we cannot solve all the types of the questions because we have the limited time. You already. So they are saying find the time after which the block stops and also calculate the displacement of the block. Basically, here is the block, and I think some more thing they have given. Here one thing given, already given, that is mu. Mu is the coefficient of the friction given. Coefficient of friction given. So this block initially moving with v naught velocity. Coefficient of friction is given, means you can say the surface is rough surface. So there will be the friction. So now we will see the mechanics. We know that this block is initially moving. This block is initially moving. So during the motion, what type of friction will be there? What type of friction will be there? Tangentially, kinetic friction will be there. Kinetic friction will be there. Okay, and there will be the weight of the block in the downward direction due to the gravitational pull mg, and normal reaction will be there. Okay, normal reaction will be there, and this block of have mass m. Okay, this block has the mass m. So this block is moving. So we can calculate this kinetic friction force. Kinetic friction force is given by mu into normal reaction. So here only one mu is given. So we will consider this mu as a coefficient of kinetic friction. So this will become Fk is equal to mu into mg. Fk is equal to mu into mg. Now we will apply the Newton's second law. We will apply the Newton's second law. So this block is not moving in the vertical direction. So there will be no Newton's second law in vertical direction because this n is equal to mg. So we will not talk about that. This block is moving in the horizontal in this direction. So in this direction we will apply the Newton's second law. According to the Newton's second law, the net force on the block is equal to the mass into acceleration and with respect to the direction. So as this block is moving in this direction, so there will be the acceleration of this block in this direction. Okay, remember. So what is the net force on this block? What is the net force on this block? Now see here, force and acceleration are in opposite direction. Force and acceleration are in opposite direction. So we will write this as acceleration is equal to net force, and we will take this force is negative. Net force divided by mass. Basically, force is equal to mass into acceleration. Newton's second law I have applied. This is the net force. Net force is equal to mass into acceleration. Net force I am taking negative because acting in the opposite direction of acceleration. So acceleration we will get, what is Fk? This is minus mu mg divided by m. So m and m will be cancelled out. So acceleration will be minus mu g. So acceleration of this block will be minus mu g. So after that they are asking, find the time after which the block will stop. This is very simple question. Suppose after certain time, due as this friction force is trying to oppose the motion, this friction force is trying to oppose the motion in this direction, but block is going in this direction. So after a certain period of time, this block will stop and the final velocity of this block will become 0. Okay. So we can apply the first equation of the motion because this acceleration is constant. Mu is constant, g is constant. So we can apply the first equation of the motion. V is equal to initial velocity into acceleration into time. So what is the final velocity? 0. Final velocity of the block is 0. Initial velocity is v naught. What is acceleration? Minus mu g, and time we want to find. So time will be, this will be minus v naught divided by minus mu g, and this will be cancelled out. So time after which the block will stop will be v naught divided by mu g, and this will be your answer. Now this is completed, time part completed, and after that they are asking displacement of the block. Suppose from this point to this point, the displacement of the block is s, suppose s. So we can apply now. Hiba, can you tell me which equation of the motion I should apply to get this displacement? Just give me the idea. First equation, second equation, and third equation of motion.
2as equals v square minus v square.
Right. Third equation of the motion. This equation we will use. Final velocity square is equal to initial velocity square plus 2 into acceleration into displacement. Okay. So final velocity is 0. What is the initial velocity? V naught square. What is 2? 2 is a number, natural number. Acceleration is minus mu g. Acceleration is minus mu g, and displacement we want to find. Now we can find the displacement. This will become minus v naught square divided by minus 2 mu g, and this will be cancel out. The displacement of the block will be v naught square divided by 2 mu g. So this will be the displacement of the block. So in this way you have to solve the question. Now there is one very famous question here. Which is easier, push or pull? Which is easier, push or pull? Basically this is the pushing, and this is pulling. This is pulling. So which is easier, Dibyangi? Just from the analysis tell, which is easier, push or pull? Means for this block, pushing on the surface is easier, or pulling on this surface is easier? Okay, no idea. So suppose I also do not have the idea. Pull. Okay, so we will see. So one by one we will see. Basically this is the force now, and this is the pushing condition, and so we are assuming that these blocks are moving in this direction. So mass of both the blocks is same. So m is the mass, so mg force will be downward. There will be the normal reaction force on the block, and we will take the component of this force. This is F cos theta, and this is F sin theta, and here will be the friction force. Okay, now what will be the normal reaction here? Normal reaction is equal to mg. Normal reaction is equal to mg. Normal reaction is equal to mg. And oh, sorry, not mg. Basically, there is no motion in vertical direction, so we will take the equilibrium of the forces. So normal reaction will become n plus, this is n in this direction, plus this is f sin theta in this direction, n plus f sin theta is equal to mg. So what is the normal reaction? Mg minus f sin theta. This is the normal reaction for this block. Now what will be the friction force? Friction force is given, suppose the coefficient, both the surfaces are same, coefficient of friction is given as mu. We have to, if we are comparing two things, so starting line should be same. So friction force will be mu into n. So mu into n is mg minus f sin theta. So this is basically the friction force that will be offered by this block. And what will be the applied force? Applied force is f cos theta only. So this is the condition. Okay, this is the condition. So consider this as equation 1, this as equation So this is the first case. Now see for this case. So one thing I have told you when we were discussing the vectors, and someone asked me the doubt, can we shift the force like this? Parallel shift of the force we can do. Okay, we can do the parallel shift of the force. So another diagram I will use. Okay, so this is the force here, and there can be the parallel shift of the force like this. Okay, there can be the parallel shift of the force like this, and this is the force. This is the force. So earlier this was the condition and this was the theta. Okay, so this will also be the theta. This will also be the theta. Okay, okay, so now in this direction, so see here why this is theta. This is the parallel to this surface and this is the parallel to this surface, and this is the angle like this. Okay, and if you are saying the force is like this, force is like this, you are shifting it parallelly. So if this angle will theta, then this angle will also be theta, na? Small maths. So basically this angle is theta. Okay, so this will become f sine theta, and this will become f of cos theta, and here will be the normal reaction, here will be the mg, and normal reaction will be like this. Okay, normal reaction will be like this. Now in
Sir,
yeah,
sir, that will be f cos theta.
this which one? Oh, sorry, very good, very good. Sorry, actually this will be f cos theta. This will be f sine theta. This is the parallel component. Okay, basically na, there is no requirement to do the shifting. You can do the here also. You can write this is the arrow na. You can do like this also, here also. This component of the force will be f cos theta, and this component of the force will be f sine theta. This thing also you can do. Okay, so I have not told you because I think that you will get confused. Then also you will get the same thing. Okay, so this is f cos theta and this is f sine theta. So now in vertical direction there is no motion, so there will be the equilibrium of the forces. So that will be n is equal to mg plus f sine theta, mg plus f sine theta. So in this direction there will be the friction force tangentially, limit friction force. Okay, so what will be the friction force? Mu into n, mu into what is n? Mg plus or f sine theta. What is the applied force? F cos theta again. So this is your equation number 2. This is equation number 1. Now compare. This is your applied force. This is your applied force. Means in both the cases applied force is same. Now which factor will decide? Which factor will decide whether the push is easier, pushing a body is easier, or pulling a body is easier? friction force will decide. So basically, this is the friction force for pulling. This is the friction force for pushing. So now, can anyone tell me uh, which value is greater, mu mg minus f sine theta, mu mg plus f sine theta? Applied force is same. So this value will be greater now. So basically, the friction force in pulling is greater than the friction force in pushing. For the same applied force, again I am repeating, for the same applied force, then you can say, it is easier to push, it is easier to push an object than pulling it. Okay, for the same applied force, again and again I say. Write down. So this we have to prove mathematically. Completed?
Yes, sir.
Hiba completed?
Yes, sir.
Okay. Completed? Dibyangi and Hiba completed?
Yes, sir.
Done, sir.
So now it's clear now, which is easier? I have shown it mathematically. Why? Because there is a more friction force in this case. Because see here, this value, why this value is less? This is something is subtracted from mg. Here something is added to mg. That is why this is greater force. Push force is greater. Push friction force is greater. Okay. If the friction force is greater, then more efforts you have to give. Okay. For the motion. Next is the angle of repose. Angle of repose. This is very simple concept. What is angle of repose? Angle of repose is basically, just I am showing what is angle of repose. Suppose, just a minute. Suppose this is an inclined surface. This is an inclined surface. Okay, this is an inclined surface. Just try to imagine. Okay, this is the inclined surface. And inclined surface means this is the horizontal. This thing is the horizontal, means this is the inclined surface now, and this is the horizontal. And see, this will be, there will be some angle between this inclined surface and the horizontal. This is the angle theta. This is the angle theta. So what will happen when I will do like this? Angle theta will increase. Angle theta will increase. Okay. Now see. Remember this point. When I will do like this, na? When I will do like this, angle theta will increase. Okay. This point you have to remember, because I do not have three hands. Okay. So this is your this is the inclined surface, this is any object. Okay, so it is very, here is the object initially. Yeah. So this is the object, say, okay, this is the object, and This here will be some angle which is now angle is less. Now this angle is increasing. Inclined surface angle is increasing. So if this pen will fall, then it will be lost. So better to take this pen. So now I am increasing the angle. Okay. So after the certain angle, the pen will fall. The object will try to move along the inclined plane, inclined plane, and that angle at which the block on the inclined plane is just about to slide, means at the verge of sliding. That angle is known as the angle of repose simply. Angle theta at which the block is just about to slide, and this is the relation. Angle of repose is equal to tan inverse mu s. And remember this point. This is very, very, I will not say very, very important, but this will we will use this in questions. Okay. Now I have told you we take the component of the weight along the perpendicular to the inclined surface and along the inclined surface. Okay, we take two axes. Two axes we take now like this. One is perpendicular to inclined plane, and another is parallel to inclined plane. Two axes we take. Suppose this is your x-axis and this is your y-axis. So axis you can choose by yourself according to the requirement. So what will be the weight component in this direction, Divyangi? In this direction, weight component in this direction. There will be the weight na like this, mg in downward direction. I have told you this angle will be theta, so this component will be mg cos theta, and this component will be mg sin theta. Okay. So basically remember these points. So basically we have now two forces, one perpendicular to the surface and along the surface. So I am removing this. No requirement of this. And of course there will be the normal reaction. Of course there will be the normal reaction. And this block has a tendency to move in downward direction. So there will be the friction force here in this direction. There will be the friction force in this direction. And this friction force will be the static friction force, because in this time this block is at rest and tendency of the block to go in this direction. And how we can calculate Fs? Mu into, suppose mu s is the coefficient of static friction between the surface of the block and the wedge. So mu s into n. What is n here? Mg cos theta. So basically in this direction there is a force, that is mu s mg cos theta. I am telling you the mechanics behind the angle of the repose. Why there is a point, why there is an angle after which that this block slides downwards. Okay. Okay. Now, what is the applied force? What is the applied force? Applied force for the block will be mg sin theta. This is very simple concept. What is the static friction force? Limiting static friction force. Basically, this is the limiting static friction force. Mu s into mg cos theta. And simple thing, we know that when you will increase the value of the theta, sin theta value increases. Sin theta increases. I am talking about for the angle, acute angle 0 to 90 degrees. Sin theta increases and cos theta decreases. So what you can say on increasing theta, applied force is increasing and the what we'll say, limiting friction force is decreasing. So there will be a point when both the force becomes equal, and at that theta, this block will be at the condition of just motion in this direction. Okay, just about to slide. Okay, just about to slide. So this is the basic mechanics behind. So here I have already written, if what is theta, I have told you. What is theta? Theta is the angle of the friction. If someone is saying theta means angle of the friction. If someone is saying theta, that does not mean the angle of the friction. If I am saying here theta, then that means the angle of friction. So basically, when angle of friction becomes greater than the angle of repose, this is the another condition to determine whether the block will move or not. This is the mechanics behind it, and this is the another condition. So this will be easy for us. So when theta is greater than theta r, no sliding. Theta is equal to theta r, just about to slide. Theta is greater than theta r, there will be the sliding motion. And remember the formula of the theta r. Remember the formula of the theta r. Oh, actually, there is a problem here. This is not the angle of the friction. This is basically the normal theta. This is basically the theta. This is the wage angle. Okay, this is not the angle of the friction. Angle of friction is different. So this is the inclined plane angle with horizontal. Inclined plane angle with horizontal. Okay, so you can see one question here. See this question. They are saying if the angle of the repose 2 and 5 seconds, in 2 or 5 seconds you can complete. Angle of repose is given 45 degree. If the angle of the repose is 45 degree, find if the body is rest or in motion. See, what is theta? This is theta basically. This is equal to theta. What is the condition here? Theta is equal to theta r. What is this condition? This block is just about to slide. Just about to slide. Just about to slide. Okay, this block is just about to slide, and they are asking calculate the friction force and the acceleration. So this thing is clear. The acceleration will be 0 because this in actual this is not sliding. In actual this is not sliding, so acceleration of the block is equal to 0. And what will be the friction force? Friction force will be the limiting friction force. Why? Because applied force becomes equal to the limiting friction force. That is why this block is sliding. So limiting friction force, that will be mu s into and mg cos theta. So this is mg cos theta, and normal reaction will be there. Here will be mg sin theta, and here will be limiting friction force. Okay, so more question we will discuss in the next class. Write down fast. So this concept we will use when we will have the next class. Sometimes they will give you the coefficient of static friction. From that you will calculate the angle of the repose. Then you will decide whether theta is greater or theta r is greater. And then you will decide whether the body is rest motion or at the verge of the motion.
Done, sir.
Okay. Hiba, completed?
Yes, sir.
Okay, so write down this first.